My name is Thomas Forbes. I'm a technical consultant at Snowflake Software, and I've been working on the aviation thread, and I'm going to talk through Snowflake's contribution towards it. So a key task was to advance the interoperable management of aeronautical and flight information, and in order to contribute to this, Snowflake generated an ISO and OGC standards compliant set of FIXM application schemas. So the overall aim of Snowflake's contribution was to demonstrate that FIXM could be implemented following the same best practices as FIXM and FIXM by adopting ISO and OGC standards. By doing this, it presents multiple advantages. For example, a reduction in the implementation cost and time for FIXM. For example, multiple vendors would be able to support FIXM using COTS software rather than bespoke software products. And FIXM and FIXM have already demonstrated that the complexity and cost of a custom system build can be mitigated by engaging in this wider open standards community and by reusing best practice patterns for application schema design. It also means that FIXM will be globally understandable because it's based on these international standards. It would also better align FIXM to FIXM and FIXM, which is beneficial because it allows them to interoperate and reference one another. For example, FIXM and FIXM share common types and patterns from, for example, GML, the ISO standard, which make them interoperable between each other, as well as saving cost and time through the reuse of globally implemented types, such as the feature model, geometry, temporality, etc. And it's this interoperability and openness that really is at the heart of the net-centric vision of SWIM. So in order to generate the standards compliant FIXM application schemas, we used an approach whereby we used Enterprise Architect case tool to modify the FIXM UML model. This is the recommended approach for modifying the FIXM model. So unlike FIXM and FIXM, FIXM doesn't adhere to the ISO standard that is the rule for application schema, and as a result it cannot be retrieved or queried or updated using the OGC's WFS specification, and is also incompatible with many COTS software packages that use these ISO standards. So in order to use FIXM via WFS, you need to have several key changes which we applied to the FIXM UML model. So principally these changes were that we extended the core features from the GML abstract feature in order to support the OGC feature model and to enable querying by feature type via the WFS. We also modified the spatial geometries and also the temporal references within FIXM 2.0 to reuse GML compliant geometry and temporal types respectively, and this enables spatial queries and temporal queries via the WFS. So these were the principal changes that we did in Enterprise Architect, amongst other minor changes. And from Enterprise Architect, we outputted FIXM 2.0 XMI and ran this through a UML to GML application schema tool called ShapeChange. This converted the XMI to a set of FIXM application schema, and these were GML compliant. Following the generation of these standard compliant FIXM application schemas, multiple testbed participants used these schemas to demonstrate the interoperable exchange of FIXM data, for example via WFS and WFST, as you saw in the diagram earlier. So to summarize, what we've shown is that FIXM 2.0 can be migrated to an ISO and OGC standards implementation, whilst maintaining a relatively similar structure to that of FIXM 2.0. And we've tried to maintain this structure as closely as possible throughout the migration process. So we've also recognized that further optimizations are possible to streamline FIXM 2.0 GML encoding, such as the including of XML attributes, and we've also recommended areas of improvement within the FIXM 2.0 model itself and related future work. And full technical detail is available in the engineering report 14037.